So this summer, I spent most of my time trying to answer this question. Can you identify this random piece of wood laying in the river corridor? And to answer this question, we decided to work in Gordon Gulch looking at downed wood. Downed wood is fallen logs and trees. Sometimes, though, in downed wood, it's impossible visually to tell where the wood comes from without doing isotopic studies. So the goal of this study was to see if we can source the location and species of the downed wood by using tree ring widths. So to do this study, we first selected two species of tree, which is the ponderosa pine and then the lodgepole pine. And then we divided the area into three zones. The riparian zone, or the channel floodplain, which is near the river, and then on the slope, the mid-slope, which is about 5 to 15 meters on the slope, and then into the upland, which is greater than 15 meters on the slope. And then for the tree cores and downed wood, we put it in the software program Windendro, which measures the tree cores in millimeters to get the ring widths. We use two main methods of analysis for these, basal area increments, or BIA, and then ring width indices, or RWI, to analyze these. So first off, RWI is a method of detrending tree rings, and it's fitted to a curve. So we can compare tree rings because all trees grow differently, and we have to standardize the tree rings to compare them to each other. So what this basically means is that when it's 1, the tree had an average year, and then anything greater than 1, that means the tree grew great that year, and anything less than 1 means the tree did not grow very well. So what does RWI tell us? Well, when looking at variance, there's no significance either across position or species. And then when you look at downed wood, you cannot identify downed wood by just using RWI, or ring width indices. So that brought us to our second option, which is BAI, or basal area increment. So what basal area increment is it's the difference in area of the tree from the start of the growth year to the previous year. So basically it's just a measurement of how big that tree grew in area that year. And we compared BAI to PDSI, or Palmer's Drought Severity Index, which is basically a measurement of how dry or wet the environment is. And if you look at the graph on the bottom, it shows us that there's a significant difference in basal area increments. So the tree grew less when there's severe drought versus when there's severe wet across all positions. So what that basically tells us is that even if the tree is near a steady supply of water, if it's a drought year, it still grows less. So what that meant is that we can use BAI to identify downed wood. And if you look at the graphs here on the left, it shows us that mathematically you can divide downed wood into groupings by both position of where they occur on the slope and by species. So once we saw that we could do that mathematically, we had to ask ourselves, is this accurate? So looking at position, the position is likely not as accurate because most of the groupings, such as downed wood 2 and downed wood 3, group with the upland position, which is unlikely on the slope due to the size of the catchment of Gordon Gulch. The wood likely did not travel from upslope to the riparian. So that meant that position by using BAI was not accurate. However, when looking at species was more accurate when trying to group by BAI. As you can see, down 2 and down 3 group with the lodgepole, which is more accurate. And then, so overall, our conclusions were, it is possible to map by BAI downed wood positions, although it's more likely to be more accurate with species than position. And like many people probably don't necessarily think that this science is important, but overall, we see trends in the bigger idea that vegetation is changing due to the aridity of Colorado. As we can see in the graphs and the trend, as Colorado gets more dry, we see that vegetation, especially trees, is likely to become smaller. And then, so I would just like to thank all these guys for funding for the research. Oh my goodness. And I would love to answer any questions if you have any.
Thank you. That was great. So the floor is open for questions. You can put them in the chat or you can raise your hand. It's up to you. I have a question while we're waiting for everyone else to type out their questions.
Yeah.
You mentioned that you use two very specific trees. What if I live somewhere where those trees don't grow? Could I use your methods on different species, or would it not really work?
In theory, yes. You'd just have to like core the different types of trees and then base your ring width analysis off of those specific species instead of like my ring widths, if that makes sense.
That does make sense.
Yeah.
So if I did have your species of trees, I could base it off your ring widths, even if I was somewhere else in the world.
Well, the ring widths also depend on like climate conditions. So if you were in a more like wetter environment and not necessarily like the alpine like Colorado is, it probably wouldn't be a great correlation or analog. You'd probably want something specific to your climate and like positioning on the landscape. So yeah.
Okay, thank you. That answers my question.
Yeah.
What do you think is the most, oh wait, no, there's another question. I don't want to monopolize everyone's time. Christine asks, what other characteristics might be used additionally, or is ring width the best available?
Yeah, so most for doing topography and positioning on the landscape, isotopic studies is most often used because that gives you a more accurate carbon count of like the tree location. And so that's typically the best way if you want it more precise. But this way is like a more less lab focused approach. So yeah.
Okay.
And then there's other methods of standardization that could potentially be used, but we didn't like go in that direction. So